Welcome to the Master Gardener Basic Training module on soils, water, and fertility. I'm Rebecca McMahon, a horticulture agent with K-State Research and Extension, Sedgwick County. I'm excited to share with you my love of soil science and how it impacts our gardens and landscapes. For our learning objectives today, we are going to talk quite a bit about the chemical, physical, and biological properties of soil and how they work together to form healthy soils. We'll talk about soil testing and the procedure. We're going to learn a little bit about how soils are formed, their base geology and composition, and how we work to modify them. We'll talk about soil pH and soil nutrients and how they impact the growth of our plants. We'll talk about calculating fertilizer rates and things related to that. We will also look at organic matter and how to amend our soil with different organic materials, as well as things that we can do to make gardening in either heavy clay soils or sandy soils more enjoyable and more effective. So what that boils down to, if you learn nothing else from this module, we want you to understand that healthy soil helps grow healthy plants. It is extremely difficult to have a healthy plant if your soil is not healthy. We're also going to talk about planting things that are appropriate for the soils that you have and how to care for your soils to get the best plant growth. That could be such things as changing your tillage practices, choosing different types of plants, or adding organic matter to improve your soil properties. Our lesson sections for this module include our first lesson on what is soil, and then sections on physical properties, chemical properties of soil, the soil testing and fertilizers, soil biology, looking generally at soil health, and then basic principles of composting. So let's jump right in. What is soil? One of the things that is often a bad habit that everyone, even gardeners, get into is to refer to that stuff underneath our feet as dirt. And I always encourage you as burgeoning master gardeners to start referring to it as soil. Dirt is what you track into the kitchen on the bottom of your shoes. Soil is what you garden in and what you plant into. So we want to really think about and understand and respect our soil. When soil scientists talk about soil, they have a lot of different ways to categorize soil. And we're certainly not going to go into all of those different categories and things to think about. But we do want to talk about some basic terminology that's going to help us understand what exists with our soil. And so soil is divided into 5 different layers or horizons. The first horizon, the O horizon, is the organic layer, and that is the layer that is on top of the soil. So if you think about a forest, that may be the leaf litter on the forest floor. If you think about a prairie soil, that could be the dead and decaying grass roots and plant material on the top of the prairie soils. In your garden, it might simply be the mulch layer, whether it's wood chips or grass clippings, leaves, things like that. The next horizon is the A horizon, which is the topsoil. And when we start talking about soil, often that is what we're thinking about is our topsoil. So our topsoil is a mineral part of the soil. It's a mineral horizon, but it has a lot of organic matter in it, or it should have a lot of organic matter in a healthy soil because it's near the surface where that organic material can easily get worked in. The next 2 horizons, the E and the B horizons, are considered subsoil horizons. And these are horizons that have significantly less organic matter. They may have higher levels of clay and other minerals, iron, aluminum compounds in those horizons. And often, if you are dealing with a location that has been disturbed recently for a number of different reasons, whether it's sewer work or it's a new housing construction or an urban area where the soil has been disturbed. a lot of times that topsoil gets scraped off, and then you're left with the subsoil as what you're trying to garden into. And it can take a lot of time and effort to get that subsoil to the point where you can really successfully grow plants in it. The other thing that we sometimes see is during a construction project, the topsoil is scraped off, then the subsoil is scraped off or dug into, and then when they go to put it all back, the subsoil ends up on top. So that is something to be aware of when you're looking at gardening, particularly in an area where the soil may have been disturbed recently. Then the next two horizons, the C and the D horizons, are the parent material and the bedrock. And so these are the two horizons where it all starts, where the materials are breaking down over hundreds and hundreds of years to turn into your soil. So where did those horizons? So the bedrock goes down to our basic geology, our basic Kansas geology, the different rock formations that exist. And so for us here in Sedgwick County, we tend to have a lot of calcareous shale and areas of limestone and gypsum. And we'll look at a map of kind of the general Kansas geology in just a minute here. So you can look up and find out what types of bedrock, what types of rock are underneath the ground that you walk on every day. Then the parent material is other materials that may be brought in from a number of different sources. So for instance, here in Sedgwick County, we have a lot of aeolian sand, stream, and wind deposits, sometimes called alluvial deposits. So it's probably not a huge surprise to anyone that wind is a significant source of parent material for our soils here in Kansas. Uh, So the bedrock and the parent material are worked on over time, over hundreds of years by the weather. So wind, water, hot, cold, freeze, thaw actions, and over time they break down and form into our soil aggregates. And depending on the composition of our bedrock and our parent materials and the ratios of those things, they turn into either soils that are more clay, soils that are more silty, or soils that are more sandy. This is an overall map of the geology of Kansas, looking at some of the different historical geology. And you probably can look on here, find your county, and see other counties that have very much similar geology. Probably not anything that's too surprising to you if you've driven across Kansas or familiar with the different regions of Kansas. So very easy to see where the Flint Hills are, the lower Ark River Valley, the Ogallala area, lots of different pieces to our Kansas geology. And all of those come into play when we are looking at our soils and what types of soils we're likely to have. So kind of take a snapshot of this map in your mind, and we're going to move on to the next map. And I think you'll see some interesting correlations to this next map. So this map shows, on a very general scale, our Kansas soil texture. And we're going to talk and define soil texture a lot more in the next couple of lessons for this module. But overall, you can see that we have in Kansas a lot of that light pink color, that silt loam. And can you kind of see some of the geology, some of the land formations that we just looked at in that previous map? You can probably pick out the Flint Hills pretty easily. With the silty clay loam, we have a little bit of the green loam. We have some cobbly loam and some loam fine sand down in parts of the Ark River Valley. So lots of different things going on, but you can see how those all come into play together. So one of the things that I would encourage you to do as part of this lesson, if your local agent doesn't provide this already, is to do some research and see if you can find a soil map for your county and see in a little more detail what's going on, because this is a very general map and each county has a lot more detail when you get up close and look at the different things going on. So I'd encourage you to do that. We'll talk about some resources for things like that a little bit later on in this lesson as well. Now that we've looked at where soil comes from, we want to talk about what does the soil provide? Why do we care about soil when we start talking about our plants? And a saying that I've heard so many times, I don't even know where it originated from, is that if you take care of the roots, then the top will take care of itself. And so that what that means is that we're taking care of our soil. If we care for the soil, then the plant is going to be healthy. And it's not 100% true. There's always exceptions, but in many cases, the problems that we see with our plants originate in our soil. And so things that our soil provides, it simply provides a place for our plants to grow, for the roots to anchor and hold that plant in place. Um, it provides nutrients to our plants that are critical to their health and growth. It provides water to our plants. When we talk about watering a plant, often we're thinking about the plant needing the water, but really we're watering the soil so that it's available to the plant roots to be taken up into the plant. The other thing that the soil provides that we often don't think about is oxygen. And this is one of those things that when we're not thinking about that, um, we can start to have some problems with our soil, particularly when we start seeing overly saturated soils, soils that have been watered too frequently, or when we have excessive rainfall. We are losing the oxygen from our soil. And that's one of the challenges with our heavier clay soils, or even some of our siltier soils, is not having good pore space and airflow for our oxygen. So we're going to talk about all of those things later on and how we can work with our soil to make sure that our plants are getting what they need. So then we come to what is our soil? What is the soil made up of? And when we start talking about soil, again, it's really easy to start thinking about the actual mineral content, the solid part of the soil. And so 50% of our soil is made up of solids. In an idealized soil, this chart is an idealized soil. It's kind of like the perfect world. And so the numbers always shift a little bit, but we're looking at in our soil, 50% is solid material. About 45% of that is minerals, and 5% is organic matter. And then the remaining 50% of the soil is the pore space. And one of the things that might be a little surprising to you as you go through this whole module is that we're as concerned about the pore space as we are about the solid content of the soil, that both of those work together, because that pore space is what holds the water and the air, which are two of the most important functions of our soil, is providing water and oxygen to our plant roots. So in that 50% pore space, we expect about 1/3 of it, or 16% of the total soil, to be unavailable water. That means water that is held so tightly to the soil particles that the plants cannot access it. And then about 1/3 of our pore space, or 16% total, is what's called available water, meaning water that the plant roots can absorb out of the soil and make use of. And then the final third of the pore space is air. Oxygen, other particles from the air, has more than just oxygen, of course, or 16% of the total soil makeup is air. So, of course, this is an idealized soil. When we have a heavy rainfall event or you've irrigated, that air percentage may go down to almost nothing. Or when we have dry conditions, a drought, or you haven't watered for a while, that available water percentage is going to go way down and your air percentage is going to go up. So this again is kind of an idealized soil, and those things do fluctuate, but that is kind of what we're looking for with our soil. So let's look at the mineral parts of our soil. With our minerals parts of our soil, there's three main minerals that we see. We have sand, silt, and clay. And this chart is not perfectly to scale, but it's kind of designed to give you a little bit of an idea of what we're looking at. The largest mineral particle that we find in our soil is sand. And sand is considered any particle that is 5/100ths to 2 millimeters, 5/100ths of a millimeter to 2 millimeters in diameter. Anything larger than about 2 millimeters is considered a pebble or, very small rock. So sand is our largest particle. The next particle that we see in the mineral component of our soil is called silt. And silt has a diameter ranging from the 5/100ths of a millimeter to 2/1000ths of a millimeter. So extremely, extremely small. And then even smaller than that are the clay particles. So clay particles tend to be a little bit flat, and we'll look at some other idealized diagrams of some of these particles in a few more slides. But clay particles are less than 2/1000ths of a millimeter. So again, incredibly, incredibly small. Typically your sand particles, you can think about being on a beach or being in a sandbox, you can see individual particles of sand, even if they're very small. But the silt, and in particular the clay, are not visible by the naked eye. The other part of the solids in the soil is organic matter. So again, in our idealized soil, we like to see organic matter being about 5% of the soil. That could include things like decomposing plant material, decomposing leaves, things like that. That includes our microbes, so fungal mycelium, bacteria, all those sorts of things. Nematodes are living parts of the organic matter. Of course, living plant roots are part of the organic matter in the soil. And then also other creatures, so earthworms, beetles, even moles technically would be considered part of the organic matter in the soil. So both living and dead parts of the organic matter. Another way to look at that with our soil organic matter, so of our 5% of the soil that's organic matter, our living organisms make up usually less than 5% of the volume, not necessarily numbers, but from a volume standpoint. Fresh residue that is not really started decomposing would be up to 10% of that organic matter. Then actively decomposing organic matter could be anywhere from 30 to 50% of the total soil organic matter. So that's considered the active part of your soil organic matter. So that would be, again, decomposing plant materials, decomposing animal organism materials, things like that. And then the last part of the soil organic matter is the stabilized organic matter, which is sometimes called humus. Not to be confused with hummus, which is ground up chickpeas that you can eat on chips, but humus, and that makes up 30 to 50% of the soil. So humus is a little bit of a strange word, and wanted to try and explain what that is in a little more detail. Again, it is stable, which means it's not readily decomposed. The decomposition process has occurred to the point where this is now organic material that is not easily going to decompose further. And there's a couple reasons for that. One of them is that organic matter might be physically protected from decomposing activity by being inside clumps of soil, little soil aggregates, and we'll look at some examples of those in a little bit. The other reason that humus is stable could be that it is chemically too complex for most organisms to break down. So the bacteria, the fungi, the earthworms, they've broken down as much as they can, but these are chemical bonds that they are not able to break down. And so our humus, that stable organic matter, is really important for building those soil aggregates and helping them stick together, which provides us our pore space, and makes it possible for our soil to have good water and nutrient holding capacity. So the humus is necessary for those purposes. Overall, when we start looking at our soil, our end goal is to have healthy, productive soil. And so that kind of begs the question, what exactly makes a soil healthy? How do we decide what is a healthy soil or not? And maybe some of you have some ideas about that already, about what might make a soil healthy. But scientists have done a lot of work in ways to assess soils and help us decide objectively what are some signs that a soil is healthy. One of the things I would encourage you to do later on in this module after you've finished with this lesson is to go find this soils video. It is from the USDA NRCS called The Science of Soil Health Going Deeper, and it has a soil scientist talking about different parts of the soil and how you know if your soil is healthy. So I'd really encourage you to watch that video as an additional learning opportunity. So when we start talking about soil health, sometimes you might also hear the word soil quality, or how good is your soil quality. One definition that I like for soil health is the capacity of soil to function as a vital living ecosystem that sustains plants, animals, and humans. So that really gets down to the crux of the matter is it functioning as an ecosystem, and is it sustaining plant life, animal life, and of course our human lives? So this view of soil as a living ecosystem is a little bit of a shift in perspective over probably the last 15 to 20 years. Prior to that, there was a lot of focus and emphasis on the chemical part of the soil, and we are still in the process of understanding how the soil is really a living ecosystem. There's lots and lots of new research coming out every year looking at the biology aspects of our soil that is just really fascinating. So kind of how we've structured the remaining parts of this module is to focus on defining and understanding soil health by looking at the physical, chemical, and biological properties of our soil. We're going to talk about physical properties, things like soil texture and structure, which are important to soil health, but they don't tell the whole story. Then we're going to look at chemical properties of our soils, things like the pH and nutrient levels, also incredibly important, but not the whole story for the health of our soil. And then we're going to talk about soil biology, which again, very, very important, but on its own is not going to create a healthy soil. So all of these things have to be combined to give us a soil that is healthy and that is going to grow great plants. Some of the reasons that we're concerned about having healthy soils is that healthy soils really help protect our plants from drought. And for us in Kansas, drought is often a yearly way of life, or at least something that occurs one or two or multiple times over several years. And so even in a rainy year, we still have periods of time when we don't get as much rain. And having a healthy soil gives our plants and our soil more capacity to tolerate those drought conditions. So in a poor quality soil or a less healthy soil, you can see the orange line here shows the rainfall, the water availability, and the gray bar shows when water is available to plants. And in a poor soil or an unhealthy soil, water is only really available when we've had higher rainfall. Uh, Whereas if we look at our next chart here, in a healthy soil, it has much better capacity for water availability. And so there's only a couple of times when these plants are going to be stressed due to lack of water compared to the poorer soil. So that's a very practical reason why we want to have and focus on our soil health for our plants. Some things that could be indicators of soil health, and again, you don't want to just pick out any one of these things to determine if your soil is healthy or not. And some of these are more practical than others on a home garden scale. But our physical indicators of soil health are looking at the texture and structure, which is sometimes indicated by water and nutrient movement in our soils, how quickly water infiltrates, things like that. Chemical indicators of soil health, we're going to look at pH and nutrients. Also, electrical conductivity is another indicator that may be of value at some points. So doing a soil test, looking at your nutrient levels is a good way to assess the chemical health of your soil. And then the biological health of your soil can be a little bit more challenging sometimes to assess. It could be things like the amount of earthworms that are visibly present in a square foot or a cubic foot of soil. We can also test for organic matter to get a sense of what's going on in your soil. So lots of other things that could be tested, but usually earthworms and organic matter are the most common on the biology side. For more information on this lesson, What is Soil?, I would refer you to the Master Gardener Handbook, pages 2 to 6 in the Soils chapter. And of course, there's other videos and resources linked in the module.